Okay. So far we said significant figures are representing measured numbers because measurement needs a tool and tools can have different accuracies. Remember, comparing the bathroom scale with triple beam balance and analytical scale, these have different accuracies. The result of measurement have different reliability. But sometimes we are not using a measurement tool. If we are not using a measurement tool, we say we have exact number. What's exact number? It means has infinite significant figure. In other words, if I'm counting people who are talking together, there are 3 people. That's exact number. You can't have 3.1 people. What's 0.1 person? Is it an ear or a finger? That doesn't happen. That you have 3 people and 1 ear sitting there near them. So exact numbers are numbers which you don't have to use a measurement tool to come up with, like counting people, like counting football. If you have balls, football, which is used for playing footballs, the ball which is used to play footballs, you're counting. You're not using a tool to measure. You count, and you could have 6 footballs or 2 footballs. You can't have 3.25 footballs or 3.5 footballs. What's half a ball? It's not a ball. What is 0.1 person? It's not a person. It's an ear. It's a finger. So if I'm taking average of these 3 numbers, and there is 1, 2, 3, I'm counting 3 exact numbers. So when I add these together and I divide them by 3, this 3 is a counted number. It has infinite significant figure. And I look at the top, I'm adding these together. And you will probably, if you use a calculator, you will come up with an answer which has got only 2 decimal places. That's what you're supposed to do that. You add them together, round it to have 2 decimal places, and they have got these numbers 1 digit there. So you get 3 significant figures from the top if you add these together and round them, following the rules of addition. You divide it by infinite significant figure. So a smaller significant figure in division is 3 significant figure. If your calculator is giving this number is not reliable number, doesn't have right significant figure. We are supposed to have 3 significant figure, 1, 2, 3, drop these, look at the first digit drop. It's less than 5, ignore it, so you get 6.65. Can I run up arbitrarily to 7? No. Because look at the top, I don't have any of these which have 1 significant figure. They all have 3 significant figure. And infinite significant figure between the 2, 3 significant figure is what we should do. So rounding up and down has a rule when we are doing measurements. So exact numbers have infinite significant figure. Exact numbers are numbers which are either coming from counting or from an equation. So they are not measured numbers. They do not have limited significant figure. They have infinite significant figures. So I go to next slide. I'm asking you to give me the answer. Stop the video, apply the rules, and check. Did you get this answer? If not, read the book, look at the lectures, look at the recording, CSI leader, Annie, see me during lab time or office hours, talk to a tutor, whichever, or talk with your team during your lab meeting. Some people in your team could be helping you as well. All right. How about this question? Stop the video, see if you can figure it out. And check the answer. Is this the correct answer? If not, ask and you shall receive. Next. So how many significant figure in this? These are additions, and suppose they have a unit. They are supposed to have a unit because they are measured numbers. Otherwise, there is no sense of talking about significant figures. If you add them together, stop the video. Is this the correct answer? Why am I dropping these? Because how many decimal places? 1, 2, 3 decimal places. How many here? 1 decimal place. How many here? None. 0 decimal places. How many decimal places in the answer? I'm supposed to have minimum between 3, 1, 0 is 0. No decimal places. I'm canceling. And I look at the first digit I'm dropping. It's less than 5. I ignore it. So I'm left with 132 units, whatever the unit of this measurement is. So the answer has 3 significant figures. All right. How about this one? Stop the video. Is this the right answer? How many sig fig here? 3. How many here? 2. How many here? 5. We are multiplying. What is the minimum between 3, 2, and 5 is 2. I have to round this to 2 significant figures. Make sure not to make common error that some people say, okay, 1, 2, and 8 is larger than 5. I add 1 unit and I get 19. Is this correct? Of course not. If you have $188.97, can you say you have $19? It doesn't make sense. How do I make sure to avoid errors like this? It's a great idea to round up and down. Before rounding up and down, write the numbers in scientific notation. How would I write this in scientific notation? Once, twice, I move the decimal point to the right of the first digit. Do you get 1.88976 times 10 to the power of 2? Once you have done that, then you won't make a mistake because you want 2 significant figure, 1 significant figure, 2, you're dropping, you look at the first digit, it's larger than 5, add 1 digit to previous numbers, you get 1.9, and then the rest of it is clear. 9.1 times 10 to the power of 2, which is the same as 190. So make sure to avoid this type of error, which is a common type of error. All right. Again, I want to review with you conversion of one temperature unit into another. We did that in Chem 2A. I want to make sure you remember, because we do labs in this term, and you will be dealing with temperature measurements and units of temperature. So we gave you 3 formulas to convert these different units of measuring the temperature. For example, if I give you Celsius, what is the formula converting Celsius to Fahrenheit? Fahrenheit is 1.8 times degree of Celsius plus 32. So you multiply these two. Guys, 1.8 is coming from a formula. Say Fahrenheit is 1.8 C plus 32. So numbers which are coming from a formula, from equation, they are base of our measurement, but they are not measured numbers. So 1.8 is exact. 32 is coming a formula, is exact. What is the meaning of exact? Infinite significant figure. And infinite significant figure on this number. So, and we are adding these things together. So this one has got infinite decimal places. We are multiplying 1.8, which has infinite significant figure, by a number which has got 3 significant figure. So here you must end up with 3 significant figure. And you're adding these two together. This number is exact, infinite significant figure. That means infinite decimal points after 32. So I have 1 decimal point, an infinite decimal point. You're adding them together. We are not multiplying or dividing, we're adding. In addition, we say number of decimal places must be minimum. So 1 decimal place, infinite decimal places for exact numbers between infinite and 1, 1 is the smaller one. So the answer must be rounded to have 1 decimal places. I hope this makes sense to you. All right. If I ask you to convert 172.9 Fahrenheit to degree of Celsius, this was the formula. So the formula is showing that this is coming exact. This is coming exact, coming from formula. Infinite significant places. So what matters is this number that decides number of significant figure. And the answer at the end. We are giving you 172.9 Fahrenheit. If I want to determine the formula for Celsius, all right, 5.9 times 172.9 minus 32. So again, if you are subtracting, you should have minimum decimal places. This has infinite decimal place. This has 1 decimal place. So when you subtract this, the answer must have 1 decimal place. You multiply it by this exact number, which has infinite significant figure. So whatever number of significant figure is coming from subtraction is deciding that, and you will see if you try to have 1 decimal places, you're going to have 4. If you have 1 decimal places, you will have 4 significant figures. So that is the significant figure of the answer.